2035 तक अंतरिक्ष में भारत का अपना स्पेस स्टेशन होगा।
The SpaDeX mission is a groundbreaking initiative designed to demonstrate cost-effective in-space docking technology using two small spacecraft. Launched by PSLV, this mission is crucial for India's growing space capabilities, supporting ambitious projects like the lunar exploration, sample returns from the moon, and the construction of the Bharatiya Antariksh Station. In-space docking technology will enable future missions that require multiple rocket launches to achieve common goals, marking India's entry as the fourth country in the world with this technology. The primary goal of SpaDeX is to develop and demonstrate the essential technology for rendezvous, docking, and undocking of two small spacecraft, SDX-01 Chaser and SDX-02 Target, in a low Earth orbit. The secondary objectives include demonstrating electric power transfer between the spacecraft, enabling future in-space robotics, spacecraft control, and payload operations post-undocking. In the mission's concept, two spacecraft, each weighing 220 kilograms, will be launched into a 470 kilometers circular orbit. The PSLV's precision will allow the spacecraft to begin their separation with a small relative velocity, gradually increasing the distance between the target and chaser. This separation will enable a series of maneuvers to bring the spacecraft closer, ultimately achieving docking. Once docked, the spacecraft will transfer electrical power and then undock, allowing both to operate their payloads for up to 2 years. SpaDeX utilizes several indigenous technologies, including a docking mechanism, rendezvous sensors, and power transfer technology. These innovations support the development of autonomous docking, which will be critical for future lunar missions, such as Chandrayaan 4, without Earth-based GNSS support. The docking mechanism used in this mission is a low-impact, androgynous system that is smaller and more efficient than other systems. The sensor suite includes laser rangefinders and proximity and docking sensors to precisely measure distance and velocity during the docking process. Multiple test beds were created to ensure that all hardware and software components perform as required. Additionally, SpaDeX uses a GNSS-based relative orbit determination and propagation (ROT) processor, which accurately calculates the relative positions and velocities of the spacecraft. Rendezvous and docking algorithms were developed and tested through extensive simulations and validations, ensuring the spacecraft can safely complete the docking process. Once the spacecraft are docked, they will carry out a range of activities. For example, SDX-01 is equipped with a high-resolution camera for monitoring, while SDX-02 carries a multispectral payload and a radiation monitor to study the space environment and assist in future human spaceflight missions. The spacecraft were developed by ISRO's U.R. Rao Satellite Centre, URSC, with contributions from other centers like VSSC and LPSC. The integration and testing of the spacecraft were completed by Anant Technologies, Bangalore. With all tests successfully completed, the spacecraft are now undergoing preparations for launch. In conclusion, the SpaDeX mission marks a significant step for India in the field of space exploration, showcasing crucial technologies that will enable future space missions, both within our Earth's orbit and beyond.